Hey class, so we're doing another video. Hopefully I'll talk slower this time. Y'all understand me a little bit more. And who knows, we may have a special guest uh, trot on by through here. But I noticed we're having a little bit of trouble with properties of waves still. So we're just going to kind of cover a few concepts and see if we can't get these down and get us ready for a quiz that may be happening this week. So here's just a little PowerPoint and I'm just going to talk with it and try and get some of these things ingrained into your brains and so that we can be successful in this unit and move on to the next part of the unit. So the first thing we're going to talk about is amplitude. Amplitude is defined as the maximum distance that the particles of the medium carrying the wave move away from the rest positions. So I'm sure many of you have seen this example before. Many of you use it in your PowerPoint presentations. That's great. So right here, this line, this is the rest position of this wave. This black line right here is the wave at rest. So how we measure amplitude is we go from the rest position to the maximum distance that these particles are being carried. So y right here, which is a representation of the crest of the wave. Remember crest by thinking about bread and how the top of the bread is called the crust. So right here we have the crest. So from this rest position to the crest, represented by y, this is going to be an example of amplitude right here. So the particles were at rest right here, and then they moved up here to the crest, and that is a measurement of amplitude. If we move a little bit farther down from the rest position, we have the rest position of right here, and then down below we have an example of a trough, which is the lowest part of a wave. So from the rest position to the trough, which is represented by the letter Z, we have another example of amplitude. So now what we're going to do is we're going to move on and we're going to go into a real life example of amplitude. So here we have Mr. Whitley lying out on a raft. Who knows what he's doing? He might be trying to get his sunburn on or get his tan on, or maybe he's just enjoying a nice relaxing day at the pool. But anyway, so we have Mr. Whitley here on a raft. And right now he is at a rest position. He's not moving. He is just completely just still. So what happened is we have this big yacht come by and it makes huge waves. And so what happens is these waves cause Mr. Whitley to go up, and from his rest position to the top of that wave that's created, which is the crest, that is an example of amplitude. Well, once he gets to the top of the wave that's created, he's going to come back down, and that is going to be back to the rest position, but then he'll also go downwards to where the trough is, and that's the bottom lowest part of the wave, and that will be another example of amplitude. Okay, so another example of amplitude is in a longitudinal wave, and in a longitudinal wave, amplitude isn't really the main concern here. It's more of the wavelength and realizing where there's compression and then rarefaction. But here's just a little drawing of amplitude, and it's just the distance of the disturbance that's created from equilibrium. So here, this line, dotted line here, represents equilibrium of this longitudinal wave, and here we're in a rarefaction, and this is from equilibrium to the top of this disturbance, and so that is the example of amplitude in a longitudinal wave. The amplitude formula is A equals D over F, where A represents the amplitude, D is the distance traveled, and F is the frequency. And this is a formula that you can kind of keep in the back of your head, but you don't necessarily have to keep this for test purposes. So the next thing we're going to cover is wavelength, and it is defined as the distance between two corresponding parts of a wave. So this is kind of the easier term that you'll have to learn, in my opinion. So here we have a crest right here represented by Y, and then we have another crest over here that's not represented by anything, but we know that it's a crest because it's the top of this wave. So from Y to the top of this crest, we have wavelength. So this is the distance from one crest to another crest. Down here we have a trough represented by Z, and then we have another trough over here not represented by a letter either. But we know from this trough to this trough is another example of wavelength. So here I have just a really rough sketch of a transverse wave. We know this is a crest, we know this is a trough, a crest, and then another crest. So from this crest to this crest, that is wavelength. From this crest to this crest, that is wavelength as well. And from this trough to this trough, that is wavelength as well. Here on a longitudinal wave, which this is another really rough sketch, we have right here where we can tell that this is a compression. We have another compression right here, and we've got a rarefaction right here, and we're kind of beginning to go back out to rarefaction over here. So on a longitudinal wave, you measure wavelength from compression to compression and rarefaction to rarefaction. So here we've got a compression. So from here to this compression over here, that would be an example of wavelength. And from this rarefaction to this rarefaction, another example of wavelength, as you can see in the background. So the wavelength formula is wavelength equals speed over frequency. So that's something you're definitely going to need to know for your test. So I'll make sure you write that down. The next topic we're going to talk about is frequency. Frequency is defined. Okay, sorry, I had to be a little referee with the dogs there for a second. So frequency is defined as the number of complete waves that pass a given point in a certain amount of time, and this is measured in hertz on your test. So in this one, we have a measurement of 1 second on this image. And so we're going to measure how many cycles have passed in this 1 second. So from here at the rest position, we go to the crest, down to the trough, and back to the rest position. That's 1 cycle. So then we go from rest position to crest, down to trough, back to rest position. That's 2. And we go from crest to trough to rest position, and that's 3. So this is a measurement of 3 cycles per second. So the frequency of this wave will be 3 cycles per second. In this image, we have Mr. Whitley once again, and we're going to do a little measurement of his brain waves. So from here, we're going to say it's worth 5 seconds. And we're going to measure how many brain waves we can measure. So we've got up, crest, and down, trough, and back to rest position. And we counted 1 brainwave. So in 5 seconds, Mr. Whitley will have 1 brainwave occur. So maybe Mr. Whitley might need to do a little bit more studying. The frequency, this is Zane. Say hi, Zane. Zane doesn't have very many frequent brainwaves either. He's a little slow sometimes. But anyway, so the frequency formula is F equals W times S, where F is frequency, W is wavelength, and S is speed. So F equals W times S, frequency equals wavelength times speed. And that is all for our learning today. So I hope y'all have learned a lot. I hope you took some really good notes. Watch it again if you didn't. And hopefully now you have a little bit of a better understanding on these 3 topics of this unit.